Welcome back, everyone, to the eCoreAcademy e-learning platform. Today, my name is AJay Raj, and I'm back with yet another geometry video. This video is going to be a bit of a bridge into Algebra 2. I wanted to start to move into more complex conic section shapes, and then later on we'll move into a bit more of our complexity with trigonometry as well. And then we have some other proofs to clarify at the end of this geometry. And the way that I've structured this is so that all of your previous knowledge, things that you learned in your previous lessons, will always be held accountable for these lessons that are going to be coming up soon after and consecutively after, so that those topics are fresh in your mind. And I won't necessarily ask you to recall items that you might remember loosely as things that I haven't specified concisely, so that you need to memorize at the beginning of this course. So some things that you might not necessarily understand, some formulas that you might not necessarily remember, those are some items that you most definitely will not be asked to memorize now, unless it was otherwise specified or called for. But today we're going to be looking at parabolas. So you might be thinking, well, aren't parabolas all in algebra? Like, isn't that an algebraic topic? What everything's basically revolved around? Because if you think about it, algebra is entirely revolved around the graph. All of these relationships that we're looking at, these situations, real life applications, in a calculating manner, where you're trying to find exponential graphs, and then of course your parabolic shapes, in which you're trying to find an eventual increase and decrease, that decline, that arc that you're going to have. It's an eventual state, something that you see in reality. Today we're going to look at more of like its geometric properties, in which how parabolas actually resolve to actual shapes, how they are shapes, and I will go into depth with that on our conic sections, how it's actually derived from something called the double napped cone. But for now, we're going to be looking at it as it would be in algebra. So we're going to look at some unique properties of parabolas and, of course, their different kinds of equations. So this is going to be a bit of a shorter lesson, but then again, don't take it for granted. There's a lot of interesting information here. It should be a good review and should help you for Algebra 2. So let's take a look at parabolics. Parabolics is an overarching theme. These are real-life applications for a parabola, basically. And parabolics revolves around and basically states that parabolas are not only your equational form and your curves that you see on the graphs, and not those equations that they represent, but it's also about real-life applications and how you can actually calculate those and relate those through geometric reasoning. So parabolas, its geometric definition for parabolas are conic sections formed from an intersection of a double napped cone that has a fluid curve extending out infinitely in one direction. We know one thing: parabola is oftentimes referred to as an obscured line, in which a line extends infinitely in both opposing directions. However, parabolas, they go and extend in the same direction, meaning north, east, west, or south. They increase in that same general direction, and they're going to increase infinitely. And of course, they're going to originate from that starting curve, and it branches out into two. It's almost like you're taking, your straightened line and kind of bending it around a certain point. And once you bend it around that it's called the vertex, where the actual parabola starts. It can be a maximum or a minimum value, but then again, don't worry about that stuff. We're going to focus more on the geometric applications for parabolas. But overall, where your vertex is where the parabola itself starts. That's basically the point in which your line is bent around to develop that curve, which gives parabolas their defining characteristics. If a ball were thrown into the air, a parabola could be used to map its movement. So that's one of the most common real-life applications given, and just a simple example of how it would be represented in real life. And if you think about the movement of any object, gravity is always going to pull it down. So you're going to have some sort of starting force when you're throwing an object, such as this kid throwing a ball on the baseball field. He's throwing the ball upwards as much as he could with that forward momentum that he's already building up, and the force through his muscles, in which he can actually launch the ball. But once it's going to throttle up, it's going to reach a maximum point in which gravity will start to take control. And once gravity starts to take control, the ball will start to arc downwards. And this is one fluid arc, actually. So that's why parabolas have that defining curve. And parabolics in real life have that defining curve. And in this case, for this movement in real life, most likely almost all the time, you're going to have a maximum value, meaning that maximum value is going to be that vertex at the very top, the highest point in which the ball in this case is going to reach the highest altitude until gravity starts to overtake that turning force, that opposing force. Let's take a look at the equations of a parabola. So this is similar to the circle video in terms of structure. So we're going to take a look at the two different types of equations for a parabola. The first type, probably you should be familiar with. I know that many times you might think of, the vertex form, which is coming up later, but the standard form is by far the most important when it comes to calculators, books, methods, any types of more complicated methods. Everything's going to be input into terms of standard form. It's your standard, but you're going to revolve everything around. So the standard form of a parabola is y equals ax squared plus bx plus c. And this equation helps in identifying the intercepts of a parabola, which are substantial points in graphing it. So overall, what this equation really does, it's really meant for, just as your graphing form and your standard form for a circle, the standard form for a parabola, it's much easier to actually graph that given equation when you're given y equals ax squared plus bx plus c. It's much easier to do so. And in this manner, you're actually going to be able to derive not only developing the graph itself, it's much easier to actually develop the graph itself, and also to input those given points because you know exactly where everything goes. So in this case, I'm just going to write this down here. So standard form. Through standard form, in general terms, it's easier to graph. You can find the intercepts of a line. And why is this important? How is this going to be derived from this equation? Well, intercepts are going to be very important as you get into algebra 2. But intercepts are basically when there are points that intersect either the x or y axis. And in this case, you see here, it intersects it at one point, and that's the origin, and that's its original vertex in this graph. So that can easily be found if you did not know that from a visual representation, and you wanted to actually graph a given parabola. What you could do is you could merely set your y and your x values to 0. So when y equals 0, you would get your x-intercept. And then when x equals 0, you would get your y-intercept, yes. And that comes into this equation right here. You just plug in 0 for each value, and then you plug in other values to solve for, to find what the other given value is. And that makes sense in a graphical point of view. That's why it's much easier to translate this equation into a given graph as such. So as you can see, when x equals 0 on this graph, we know that y is going to equal 0. And when y equals 0, that means you're also going to find your x-intercept, which is also 0, because that vertex is at the origin. Equations of a parabola part 2. Let's take a look at the vertex form. Probably much easier, something that you started off with when you were thinking about parabolics in general. So the vertex form of a parabola is y equals a times x minus h squared plus k. Now, you're already expected to have known this and have a good grasp of this coming into geometry, but I'll do a quick review of this. I'm trying to just get you guys used to this, and I'm going to show you how to a new equation for different properties of a parabola that only correlates to geometry. So the vertex form is useful in identifying the vertex of a parabola. Hint, hint. Therefore, that's why it's called the vertex form, and it's much easier to derive the equation from a given graph utilizing the vertex form. It's basically a kind of opposite from the standard form. Standard form is much easier to translate into a graph, but it's easier to derive the equation of that graph when you're given that graph into your vertex form. So I just want to give you a little bit of a recap of what this vertex form, or general form it's called, really stands for. And it's f of x, or your y value, equals a times x minus h squared plus k. And what your a value is. A is basically your stretch value. So basically, when your a value is greater than 1, it's going to start to basically it's going to start to compress that graph, actually. And it's going to start a vertical stretch. So when you're stretching it out from a vertical point of view, it's going to start to get narrower. And if it's less than 1, if it's a decimal in between 0 and 1, then it's going to start to widen outwards. If it's negative, it's going to reflect across the x-axis. If it's positive, it's going to stay upwards. You're expected to know that. But if you don't know that, please refer to Anita's Algebra 2 video. She goes through all of this extensively. And it's very important that you really get used to that. So if you, I will leave a link into that video. So please watch that video first if you're confused. I highly recommend those videos. And I'll leave that link in the description so you can come back and really understand these a bit more complex topics correlating to geometry. So then we have A equals our stretch value. H is going to be our left and right movement, left and right shift. And K is going to be our up and down, so vertical shift. Yeah, that's basically it. So once you look at a given graph and you're given the vertex, what point the vertex is, that's all you really need. Because once you put in that vertex, you can plug in other points you see on the parabola like that to find out what your a value is. Much easier than the standard form equation. And the only possible way that you could utilize that property is, and the easiest way to do that is if you actually put it into your vertex form equation and then actually FOIL it out, factor it out, expand it out, and get that standard form equation. Now we're going to look at what the meat of this lesson really is about. So now that we've introduced parabolas, hopefully you guys aren't as rusty anymore. A bit of a review is always necessary. We are going to focus on the directrix and focus, which are the two main focuses, foci, you could say, which is going to be the focus of today's lesson. So these are two new properties that we're going to look at. So let's take a look at what the focus is. So the focus is a point on near a graph. It's a point on a graph. And it's the distance on any, sorry, let me just clarify. It's a point on a coordinate plane. Let's not say that on a graph because it could be determined as if it were on a parabola. No, it's not on the parabola, but it is somewhere near the parabola. So the focus is a point on a coordinate plane. And the distance on any point of a parabola to the focus is a point same distance to the directrix. So I'll explain exactly what that means. So if we take a look here, the focus is a very unique property of a parabola. So the focus, I'll write it down here. The focus is basically, it's a point on the inside of a parabola. And also, the focus, I just want to highlight this, focus is on the same vertical axis as the vertex. So what exactly does this mean? So a focus is basically any point on the inside of a parabola. And the focus will always have the same y value as your vertex, but it won't be on top of that vertex. So it'll be on the same vertical axis as your vertex. And it's another point on the inside of the parabola, not on the exterior. The directrix is something on the exterior, and the focus is going to be determined by the directrix, and the directrix is determined by the focus. So basically, a focus is going to be the same distance between any point located on your parabola as shown as the same as the directrix. Now, there's a formula to calculate what that focus is, and then you can utilize that value to determine what your directrix is. But now let's take a look at directrix and focuses part 2, foci part 2. And now let's take a look at what the directrix is. And a directrix is actually a line, and it's the same distance from any point on the parabola to the directrix. It's stating that the distance from any point on the parabola to the directrix is equal to the distance from the same point to the given focus. So the focus is the same distance from any point on a parabola to the directrix. And just as a little recap, don't worry if you're still confused. I'm going to go through an entire problem about this. But just to put this out there, hyperbolas and ellipses, which are other types of conic sections, have 2 foci and no directrix. That's because they're basically doubled up and they kind of are resemblant of circles. A hyperbola is basically a double parabola, one on top, one below. And then an ellipses is basically your ovular shape. So I'm going to draw this out here. So if we have a given parabola, say, for example, we don't even know what the equation is. That's not important to us. If you have a given parabola here, where is our focus going to be? So let's say that this is our vertex of our parabola. We know that our focus is going to be somewhere on this vertical axis here, somewhere on this axis, with the same y value. So let's say we find what our focus is. Let's say our focus is right here on the center. No points. We're not concerned about that. Now we know that say for example, we know that our distance between our focus and our vertex is going to be 2 units. Well then, we know that our directrix is also going to have a point, a central point, that's going to be the same distance from the vertex same distance that the focus is from the vertex as the vertex is to the directrix. And the directrix is going to be on that same vertical axis. And keep in mind, it's actually a line. So this, let's say we find that central point of our directrix. The directrix in this case, when it comes to x squared values, when you have your parabolas going up or down, that value is always going to be an x value. It's always going to go straight across horizontally. So our line would look something like this for our directrix. It would look something like that. This would be our directrix. Almost said vertex there. Let's say our directrix. This is our directrix. And this is always going to be an x equals value. So it's going to be always an x equals value in this case, and it's going to be 2 units away as well. Because it's a line, it's x equals. I'm sorry, because it's a line, it's y equals. I apologize. This term, it's going to be y equals. And for the problem that we're going to do, it's the last slide. I promise we're going to get through this real quick. But when it comes to this lesson, I'm just going to go over values that are going to involve x being squared. So when the x value is squared for a parabolic equation or a parabola equation, a quadratic equation, you know that your parabola is going to go straight up or straight down, and I'll explain that in a later video. But I'll also do another video on focusing upon the y value when the y value is squared, and that's going to be to the right like this or to the left. We're focusing on up and down with x values, just to keep it simple. So this is practice with horizontal axis. That refers to your with your horizontal axis. That should say vertical axis. I apologize, but we're going to focus on the vertical axis. So let me just cross that out. Let's say vertical. Focusing on vertical only for today. Vertical axis meaning it's moving, it's going up or down. So we're going to find the directrix and focus of the graph. So this is our given parabola here. We're going to use the equation f equals 1 over 4a from the vertex form of a parabola to find what the focus is. So this is the equation for the focus. Yay! So with this, we can also find out what the directrix is as well. This is the equation for focus. And say I'm going to give you the actual equation here. So let's say that f of x, or let's just put it in terms of y. So let's say that y equals 5 times x minus 3 squared plus 1. So that's our value right there. So basically that means that this is our vertex form equation. It's in the form of y equals a times x minus h squared plus k. So this is going to be our a value, this is our h value, and this is our k value. Now what the equation's asking for, or what the problem's asking for, is to find the directrix and the focus of the graph. So we know that the focus is going to be 1/4 there. So let's actually go ahead and start that. So we see that f equals 1/4 times your a value, which is 5 in this case. So 1/4 times 5. That means that f equals 5/4. All right, so we know that it's going to be 5/4. And since we know that our value of f equals 5/4, let's find out what the actual y value of our given equation is here. Because keep in mind, it's going to be on the same vertical axis. And when you think of vertical always is determined by whatever x value you have. So in this case, we're trying to find out what the given y value is of our vertex. So we know here, if we look at our equation, the vertex in this vertex form, which you're already expected to know, is negative hk. That's our answer here. So we see that -3, 1. We see that we're going to -3. We're going to do the opposite sign of -3, and that's going to be 3. So it's going to be 3, 1 here for our vertex. So we see that our y value is going to be 1. And we see that our focal point here is going to be 5/4. So we know that our f value is going to be 5/4, we know that it's going to be basically our 3, 5/4. So we're just going to calculate the distance between 5/4 and 1. We know that's 1/4. So we know that the directrix has to be on the opposite side of the vertex. So we're going to do 1 minus 1/4 to get 3/4. And the equation for our directrix would be, let's put that into a colon. Our equation would be y equals 3/4. So those are our answers. So our focal point, our focus would be our 3, 5/4. And our directrix would be y equals 3/4, because it's a line. And the focus is a point. All right, everyone. So that'll be it for today's video. I hope you guys enjoyed. I had a blast making this video. Please make sure to like and subscribe, and also comment down below if you have any questions, concerns, or if you just have any feedback for us. Hit that post notification bell so you don't miss out on any of our later uploads throughout this course at our eCoreAcademy e-learning platform channel, as we also have a website available to you as well at www.ecoreacademy.org. We'll have the link in the description as well. Please check that out. We have full unlocked access to what we as an online e-learning platform actually offer. We have quizzes, note sheets, worksheets, etc., and progress checks that go along with each and every single one of these videos on our YouTube channel to give you the full curated experience. Check out our email at eCoreAcademy. Use our email at eCoreAcademy@gmail.com. It's down in the description box as well if you have any questions, or if you just want to reach out. And also feel free to check out our socials. Full link is in the description box as well, at Facebook, Twitter, and Instagram. See what kind of interesting content we have there, and use those mediums to share all of our videos. Once again, everyone, I had a absolutely great time making this video. Wherever you are, I really want to show thanks for the support that you've been showing our channel and our website lately. We really, enjoy making these videos and want to really give back to the community. So we thank you for all of your support. So that'll be it for today's video. I hope you guys enjoyed, and I will see you guys in the next one. Peace.